Hello everyone, welcome to another video of Programming Problem Solutions. In this video, we will continue to explore the two-sum problem that we explored in the last video. Just to recap the problem statement, the problem states that we will provide a nums integer array and a target value, and we need to return the index of two distinct elements in this nums array that when added leads to the target number. In the brute force solution that we saw in the last video, to find the index of such elements, we used a two-phase approach. In the two-phase approach, what we did was, we had to go over the complete array or slice twice. We had one pointer at one of the elements using the outer loop, and the next pointer would scan over all the elements in the array. And then, if we didn't find the solution, we moved the first pointer to the next element, that is here, and then again, we would scan the whole array to find the second element, and this would go on until we find two elements that add up to the target value. Whenever you use a two-phase or two-pass approach to solve a problem, that is, two pass over the array to find the solution, the first thing you should look at is if we can solve the problem in only one pass, that is, by only going over the elements once. To solve the problem in one pass over the array or slice, we are going to use a map. The map that we are going to use will be of integer keys and integer values. The key will be the actual elements in the array, while the value that we store will be the index of that value. So what we will do is, when we go over the array, along with going over the array, we will use the map to store each element with its index. To visualize things, let's take an example of the same array that we used in the last example. And again, we are having a target of 7. So in the first iteration, I will be at 1. Since there's no element in our map, I will add 1 with index 0 to the map. Next, I will go on to the next element in the array. Since I have an element in the map, I will check if 2 plus 1 is equal to 7. Since it's not equal to 7, I will just add it to the map with its index 2, 1, and move on to the next value. When I am on 3, we will again check if there exists a number that when added to 3 leads up to 7. So what we will do is, we will see 7 minus 3 is equal to 4. We will check if 4 exists in the map. Since 4 doesn't exist, we again add 3 and 2 the index to the map and move on to 4. This time what happens is, I do 7 minus 4. I need 3 in the map to find the solution. Since 3 already exists, I can say we have found the solution and we can get the index of 3 from the map. So I already know that I am at index 3 in the array and we have a solution, or we have another element at index 2 which is the solution. So at this point we can return 2 and 3 as the result. So both these elements 3 plus 4 is equal to 7, and this is our result. Let's now see this with a code example. Here I have the two-sum function which takes nums, which is an integer slice, and a target value which is again int value, and then we return a slice of int which should have the indices of the solution. First up, I create an empty int slice to store the indices of the solution. Then I create a num map which has int keys and int values. It is an empty map at this point. Next, what we do is we iterate over the numbers. If you range over an integer slice, the first iteration variable is index and the next one is element. So I is the index and L is the element. Inside it, I check if num has a key which is equal to target minus the current element. If it's not equal to 0, that is, we have found a value, we append the index, the current index, and the index from the map, which is num map target minus element minus 1 to the result slice and then return slice. If we don't find a match, what we do is add the element as a key along with the current index to the num map, so that in next iteration, if we have another element and when added they add up to the target value, we can return it. If you notice, what I am doing here is when I am storing the index in the map, I am adding 1. That is because in Go, if you have a map and try to find a value that doesn't exist, you will get the 0 value for the integer type, which is 0. To distinguish between if the value exists or not, I am just adding 1. Since num slice can have an element at index 0, and if we get 0 return, we can't tell if it's an actual value or a 0 value. So to compensate that, I'm just adding a 1 when I'm saving the index. Please note that when I'm returning it, I'm also reducing 1 because the index of elements stored in num will start from 0. After completing the for loop, if we don't find the solution, we return an empty slice. So here we have the same slice and we are calling toSum with nums and target 7. Let's run our program to see what we get. As you can see, 3 and 2 is returned, which is elements 3 and 4, which add up to 7, which is the correct answer. With this approach, we are only doing one pass over the nums array or slice in our case. Let's now compare the time and space complexity of the solution to the brute force solution. Since we are only doing one pass over the array, the time complexity of this solution is O(n), where n is our number of elements in the array or the slice. The space complexity of this solution is O(n), where n again is the number of elements in the array. This is because we are using an external map to store the elements as we pass through them. So that is the trade-off we make. In the brute force solution, the time complexity was O(n square). We have reduced it to O(n), but we are using some extra space, which is O(n), which in brute case solution was constant. We are making some trade-offs to get a better time complexity. This is something that you should keep in mind when finding a solution to a problem. That's it for this video. I hope you enjoyed it. Please feel free to ask any question that you may have by commenting under the video or by reaching out to our Discord server. See you in the next video. Happy coding!